joining. That's nice. That's nice. Thank you so much for your reactions. As I'm every time mentioning, it's really important to see that you are alive here, that you can hear, because like this I can focus more, because I know that people are listening to me. So once again, my sincere apologies for yesterday's meeting. Unfortunately, we were not able to have it, but no worries. Our program is fitting perfectly. We will not miss any topic or something. We will have all the topics which we're gonna have. So no worries. And yeah, probably some of you don't know me. My name is Alina. I'm an educational facilitator in RTsim company. Me and Diana are in the same position. So sometimes most of the sessions of the bootcamp I hold as a moderator of our sessions with speakers. But nevertheless, sometimes technical also can be mine, let's say. I also know the program. So today's topic is going to be a mind treatment unit. I hope you're ready. And as I see here, there are some participants of our RTsim training. So for you, it should be one of the easiest simulator, because I guess for preparation to the RTsim training championships, you spent quite enough time in this simulator. Okay, so time is 11:03. I guess we can slowly start and move to the main topic of our today's session. As usual, if something, you can use our Google chat. You can ask questions, me or my team. As soon as we will see your answers, we will be happy to help you. Hope everything will be okay. If there will be any problems with sound, or if there will be any problems with video, my network connection, sometimes it happens, please let me know. You can switch on your microphone and start to talk. Okay, so today we will explore one of the most complex simulators of RTsim career. It's number 5, a mind treatment unit. So we will, as usual, go to training mode, and I will launch this model in technological process management mode. And as usual, program is a little bit rebooting. Okay, it stopped to screen share. Why? Yeah, I realized why. Sorry, just a second. I will do like this and like this. Now you should see everything. Okay, that's good. Let me close that windows. Okay. So, technological process management mode, a mind treatment unit. And as usual, to make the workspace much more convenient, we suggest you every time to use technological flowsheet mode and to push a start button. So, in this simulator, there are a column, as you can see, 2 pumps, and a heat exchanger. And natural gas enters the column for purification, and it is fed to the bottom of the column, rises to the top of the column, and is purified thanks to the monoethanol amine entering the top of the column. And gases that are formed in different production processes during oil refining entering for purification in our column. Commonly, gases collected from several units and directed to this column for purification. You can see my screen? Can please everyone check, because as I see, everything is seeable.
Yes, we see it.
Okay. So, Abu Bakr, please, maybe you will re-enter to the meeting, because as I see everyone seeing the screen, and everything should be okay. Yeah, maybe there is some problems with your internet connection. I suggest you, okay, that's good. Okay, so coming back to a mind treatment unit. Gases that were formed in different production processes during oil refining entering for purification in our column. So commonly gases collected from several units and direct to this column for purification, because it increases economical efficiency and environmental compatibility. Therefore, everything that can be recycled is always recycled by the production, because our main goal is to make it economically efficient and to earn as much more money as we can. So after purification, the gases that came out from the top of the column used as fuel fuel gas for the furnaces, and fuel gas must contain fully combustible components like carbon dioxide, carbon monoxide, methane, and some other gases that do not pose any danger. But natural gas consists sulfur, and hydrogen sulfate is dangerous because the furnaces, due to sulfur corrosion and burners destroying. So an amine treatment unit clean fuel gases of hydrogen sulfate, and also hydrogen sulfate combustion products, which are called mercaptans. And they are crazily pollute the atmosphere. And we can monitor the amount of hydrogen sulfate in gas using the concentration in our device, which is named AE002. Let's open a transfer this device, just so it will be seeable to you. And A at the beginning of the device name means concentration. Usually, like I also don't know why it's A, but usually we're naming it from, for example, P is pressure, T is temperature, F is flow rate, but remember that A is concentration. And in this case, we can see that this is the concentration in percent terms by mass. As you can see, percentage by mass. Unpurified gas with a hydrogen sulfate content of 30, let's say 0.5, 30.41% passes through column, and the column is irrigated by monoethanolamine, and the gas comes out cleaner. As you can see in this device, which is AE01, is showing to us that in general, the gas become much more cleaner, as you can see, because our percentage by mass is in much smaller amount. So it was 30 here, and it became almost 15, let's say, percentage here. So and the gas come out much cleaner. And as we can see, it becoming less. And it is impossible to clean gas perfectly, but we strive for the least amount of hydrogen sulfate. So in general, our goal in this exercise is to make this number as much less as possible. And monoethanolamine, in turn, enriched with hydrogen sulfate, comes out from the bottom of the column, from here. And this is pumped. As you can see here, we have two pumps, and goes to the heat exchanger here. And from heat exchanger to the boundary of the installation. So, in fact, contaminated monoethanolamine can also be recleaned and again go to regenerate the incoming gas. Yeah, from here it's going actually like this. It can be recycled because, once again, our monoethanolamine is crazily expensive, and our main goal in every exercise, let's say, and not just an exercise in real life, is to make it as much more economically efficient as possible. So all the products which can be used once again, most of the times, it's really cheaper to reclean it instead of using something again. So here we also can see two pumps, and at the plant, and any dynamic equipment is duplicated. Why? Because it breaks down much more often and most often, and to avoid any emergency situation, such equipment is always duplicated. I guess you also can logically understand it, and also most of you knew this information. So pump under the letter A is the main one, and pump under the letter B is a backup. And also we have here 4-level device of the column. You can see it here. One device is an alarm device, and we monitor the signal values of the yellow contour using it, because as you can see, also numbers here are, I would say it's orange, but let it be yellow. We call it usually yellow, so let it be yellow. And it will light up in a pre-emergency state. The other 3 devices which have second letter Z in their name. These three devices are linked to the emergency protection. And three devices will flash red in the event of an emergency and start a chain of processes that prevent an emergency situation. Why? There are three of them, not one. Although they all have the same indicators, they have the same name, just numbers different, they showing the same. Why not two? Why not four? Why especially three devices we have here? I will suggest you to answer in chat. Think why it can be like this, why we have three devices which showing to us emergency situation rather than one or five or four. Why it's not one? Why it's not two? Why it's especially three? We also can logically understand this idea. So yeah, do not spend time. This is a safety rule. And let's say it may happen that two devices show correctly and one is broken. And then the majority decides, that is, if the majority decides. So if two devices show emergency values, this means that emergency happened. And the entire installation must be blocked. But if the majority of devices tell us that everything is normal, so everything is normal. So usually in plants, it's 3 or 5 devices which are showing to us emergency situation. I've never saw 7, but it can be also, I guess, maybe just in my experience it didn't happen. Usually it's 3 or 5. Yeah, so we have here 3 devices. Okay, so the first thing which I suggest to do is to look at the effect of amine intake on the absorption process. So this is an absorption column, and monoethylamine is fed to the top of the column, and to increase its flow rate, So to increase its flow rate, we can open the control valve even more. So for this, let's go to DCS. And let me remind you that all control valves are controlled by distributed control system. So we're pressing DCS, we entering to control room. Yeah, control room. And the raw material control valve FV001 is controlled by the flow rate device named FIRCO1. Let's go into it. Let's open the panel. And as you can see, it's in automatic control mode. And in automatic control, we can adjust new set point. So we can now change the set point to a higher one, but I suggest switching to manual mode. So we will switch the device to manual mode. And let's open the valve in the MV window to 65%. Okay, 65 and enter. So basically, of course, these meanings will be kind of just we will use it manual mode and MV window to make the set point in percentage. So it will be easier for you to not remember all the numbers, but to make it in percentage because, like, let's say it's easier for understanding. And let's see what we can observe. I will right now open the trend by the device, by the level of the column cube, LIRCA4. Let's open trends for this device. And let's also look at the concentration of hydrogen sulfide at the outlet. This is the outline concentration device, which I already showed you, AE01. Let's open also trends for this device. Okay. So right now it's seeable, right? Right. It is clear that the level of the column cube increased slightly, but when returned again to 50%, I will make it a little bigger so that you will see the difference. Probably it's not seeable when it's small, but yeah, here you can see that it increased slightly, and after that returned to 50% because it's in automatic mode. And because we increased the flow rate of the liquid component and monoethanolamine. Yes, sorry. I will make it a little less again. So monoethanolamine is a liquid, and due to this, the liquid began to accumulate in the cube of a column, and the level in the cube began to rise. So the level in the cube returned to 50% because the LIRCA4 device, in conjunction with FIRCA3 device, it's not in automatic mode, in cascade mode, in cascade control mode, leveled the level in the column. Because as you know, cascade mode is working like hands and eyes, so level device monitoring the level and giving the information to the control valve, which controlling control valve, controlling the situation in the tank, in the column. So the cascade control mode leveled the level in the column. And according to the trend of the how can we zoom in and zoom out? What do you mean under zoom in and zoom out? You mean the whole screen, entire screen, or just the trends window? Okay, so I will keep going while you're writing. And according to the trend of a concentration device, AE001, it is clear that the amount of hydrogen sulfide began to fall. As you can see, it's already 9% because also I weigh a lot, and this is a good indicator in general. This happened due to the fact that the amount of contaminated gas remained the same and the amount of monoethanolamine increased. And accordingly, monoethanolamine can now absorb an even larger volume of gas for cleaning. So as soon as we will go with time, it will become less. But we can also change the gas supplied amount for cleaning. So we will manipulate the manual valve, and accordingly it is controlled from the field. So let's clean on Z1 manual valve. It's here. Yeah, and close it by 50% with the mouse wheel. So smoothly you're doing this process and closing it by 50%. Okay, we've reached 50%, and we can see right now that the flow has dropped from almost, it was almost 2,000 kilograms per hour to 500, as we can see 600 here. Yeah, you can see it according to the trends of the flow rate device. Right now it's almost 628 kilograms per hour. And we have sharply reduced the amount of gas supplied for cleaning. So this has led to a drop in pressure in the column also. And we can see it in the Peer 4 device. I will also open you a trend for this. Yeah. So this happened because it is the gases in the column that create the pressure that was here, and it dropped sharply. So due to this, the level in the column increased because pressure was created, due to which monoethanolamine quickly flowed into the column through a pipe due to the pressure difference. So according to the FIRCA1 device, which is here, we can see that the flow rate has increased significantly. As you can see, 1, 2. It has now stabilized, but there was a jump, as you can see here. Right now it's going straight, but in general there was a jump. And we also see that the level in the column continues to grow according to our level device here, FIRCA4. Yeah, and now the FIRCA3 device will be triggered. Let's find it. Yeah, this one. It will be triggered, which regulates the level in the column cube, and the level will decrease again. Okay, so, but the most important thing in this case is that the device for the concentration of hydrogen sulfide at the outlet, at the AE1 outlet, the graph of hydrogen sulfide concentration at the outlet of the column fell even lower. So you can see it here. Right now it's 8% by mass. Yeah, so that is, there is much less purified gas again, and much more monoethanolamine which purifies. And in general, this is how it's working. As I already mentioned, soon it will come to even less number. And in general, your goal in this exercise is to make as much purified gas as possible. So yeah, that's actually it about the technological process management mode. I will right now look to the chat, and we will go to the next exercise. Yeah. We will go to normal startup. What software are we making use of? Okay, as I see my colleagues already answered here. Okay. Yeah, our technical support will every time help you. RTsim support. Support. RTsim.Twins.com. If I'm not mistaken, Denise, if you can copy paste the, or Adele, some of you, if you can copy paste the support email, it would be nice. So if you have any questions, you can every time reach to our support, and they will every time help you. And I still didn't understand about your, of course, the class recording will be provided in our YouTube, and also we every time sharing the links in our WhatsApp chat, so you can every time check the recording of the session. About zoom in and zoom out, I still didn't understand if you're meaning about the whole software and the whole screen, or just about a trans window. So let me know. About trans window, I guess I showed. So you need to just pull up and pull down in the right corner. So it's like typical user interface. If we're talking about the screen, it's a common problem of our users. So we will suggest you to change the scale of your monitor in Windows settings. So you will go to the monitor settings, scale, and there usually it's staying like 125. You need to put it to 100. So in our software, everything will also become normal. So let's go to the normal startup exercise. Sorry. So 5.2 normal startup, and now we will start the column. So as usual, immediately we're clicking to technological flowsheet button and to the start button. So we are given a column, all valves are closed, no expenses, and now we will release it to production. As you can see, everything is closed. So our main goal is to start the column. And in this exercise, the instructor tab is active. So let's click on it. And at the bottom of the screen, a list of steps that need to be taken to complete the exercise will appear. And when you're clicking on an item, the object which you need to perform the action is highlighted. So, for example, as you can see, I pressed to the first line, and that manual valve showed to me directly, because the first thing which I need to do is to open this manual valve. But I would like to draw your attention to the fact that the complete execution of a virtual instructor doesn't guarantee the maximum grade for the exercise. So, of course, you can, for example, list all the actions which you need to do. So you will need the internet. I just saw a question in chat. Why is it that we can't use internet to connect the software? If I understand your question correctly, you will need internet just to enter to the software. When you're working with the software, internet is not needed, so you can work without internet. But to enter the software, to put your login and password, you will need internet, because the system need to enter you and to check your password and login. But in general, you can work without internet. So I hope I answered your question. If it's not like this, please let me know if you mean something different. Using instructor doesn't mean that you will get the maximum grade of the exercise, because it's not simple following the steps, let's say, because you need to understand the process and you need to understand why you're doing this action, for what. In some steps of the action, you need to wait a little. In some steps of the action, you need to make it faster. Also, please remember that we also checking the time with which you're starting the column or stopping it. So don't simply use instructor. That was my point of view, especially, for example, when we will have some. Okay, actually, it should work. I guess Ethernet cable. I guess it should work. We didn't have this type of problems. I will suggest you to try again and maybe to reload the system, reload the computer to try to again reinstall the software. And also I will suggest you to write to our technical support if they already meet this problem, they will help you. And also maybe it will be nice to use AI. Maybe it will also help you. What can be the difference? Just recently I had a situation when it really helped me with my computer, so suggest you to use it. Okay, if you're asking me, it's every time better to use the reference information because it will also give you the explanation of what you should do, why, and step-by-step actions, and it will explain you better than just an instructor which showing the steps. But of course, instructor is also a super nice feature which will help you to understand the exercise. So now in the process, we will pay attention to this, and during the normal startup of the Amine treatment plant, we first will prepare the lines. To do this, we will open the manual valves. These are points from 1 to 0, so Z1 to Z9. And let's click on the first line, which instructor giving to us. So Z2 manual valve, it is highlighted on the screen, and we need to open it. So I will every time suggest you to do this smoothly because in general, this is the equipment which is on the field. So in real life, the operator going and opening it with their hands. So that's why we're trying to simulate here. Firstly, we're trying to simulate the real reality here. Secondly, it also ensures the smooth working of the equipment. So to make it maximum, let's say, working, let's also do it how we should do it. So we will smoothly open the valves with the help of our mouse wheels. Next valve we have, which are Z3. After that, we will open Z4. And like this, we will do till Z9. So Z5, we are preparing the lines right now. Z6. Okay, Z8. After that, we will directly go to Z15. And a little later, I will explain you why we didn't go to Z9 directly or Z10, why there are some of the manual valves which we missed. So yeah, Z15, Z11. Z13. I missed. Okay. And Z13. So let's see after that which manual valves I haven't opened yet. Let's go in order. So first valve valve Z001. Yeah, we started from valve number 2. Why it was like this? Valve Z number 1 remained closed because it's too early to feed gas for cleaning, because this valve is letting to gas enter to the column, and right now it's too early because monoethanolamine has not yet been fed into the column, and the gas will simply exit the pipe unpurified. So in general, our whole process will not happen and will continue along the process line unpurified. That is why we will start the regenerated monoethanol. Use the drain mostly during shutdown, and also I didn't open the valve Z007. Let me, okay, like this should be when it's on top. Yeah. Just a second. Sometimes I'm also struggling with the interface. It's normal. We will all get used to. So yeah, we didn't open the valve Z07 because it will take out the gas to atmosphere. In general, you shouldn't do this. But the main idea that it's also using mostly during the shutdown. Yeah. Cleaning and shutdown of equipment, or maybe there will be any various emergency situations. So mostly it's also to make empty the column. So next I have valves Z9 and Z16 closed here. As you can see, the Z16 is with the second pump. Because we haven't started the pump yet, and there is no point in opening the valve here yet, because there is no feedstock in the column. And the manual valve on the regenerated monoethanolamine line here, somewhere where yeah, here. Yeah, and the manual valve on the regenerated monoethanolamine line in the heat exchanger is closed because this is a hot circuit and we always start it second. So the cold circuit always goes to the heat exchanger first, then the hot circuit to the heat exchanger. Diane explained it to you in the last session when you checked and explored the work of the heat exchanger. So we do this in order to not damage the equipment. Because as you know, every equipment is crazy expensive and we don't want to put any dangerous situation. Next comes the opening of the shut-off valves. These are points 10 and 11 in our instructor. Let's go to them. Yes, so as you can see, till 9 point we did 100%. Right now we're going to points 10 and 11, so opening of the shut-off valves. And it's happening through the DCS. That's why instructor took us directly to the DCS. If you press them through the instructor open the DCS for you. And they are opening remotely. So right now let's open the shut-off valve wow, why that much reactions? We opened shut-off valve. Woohoo! So let's open it. At least your applause will be for reason. I hope this doesn't mean that there is any problems with my sound or something, and you're not trying to show me that there is a problem. Just you really like the amine treatment unit and shut-off valves. Okay. So shut-off valve U006 and U001. Yeah. Okay, let's open them. Woo! Bunch of applause! We open shut-off valves! Yoo-hoo! Okay, so let's go to the step number 12. This is Firka 001, and now we are starting to fill the column with regenerated monoethanolamine little by little. And there is already raw material in this section of the pipe. Now we will gradually open the regulator in order to check the regulator operation. So the FV1 control valve is controlled by Firka 1 device. This one is controlled by this one. So let's open the control panel. Now it's in manual mode, as you can see. Yeah, so let's open it in manual mode by 15%. So we will check that everything is okay, everything is working. I will open it by 10. And as you can see, it's also shown in the instructor. I'm showing you with my hands, like you can see my hands on my screen. So 15%, as you can see here, it's written in the instructor, to be sure that everything is working. As you can see, everything is working, nothing is broken. So right now we can, the flow appears in the device, as you can see. Now regenerated monoethanol amine began to gradually flow into the column. We can see that the device is working correctly, and we can open it more. So after that, we will switch the FIRC1 device to the automatic mode. Yes, and set the setting from 20,000 to 29,000 kilograms per hour, as our instructor shows to us. I will set the setting to 27,000. So every time choosing something in the middle. You can also try by yourself. For example, if you will put the lowest amount, what will be? If you will put the highest amount, what will be? If you will put more than it's suggested, what will happen? So it will show you in general how to work with the simulator. It will help you to understand different scenarios. So yeah, I suggest you to try something like this. So the control valve began to gradually open in order to approach the setting which we set for it. And as you can see, gradually it's coming to the point of 27,000. But right now it's less, of course, because it needs time to enter. Okay, so next we will open the shutoff valve at the pump outlet to open the path from the pumps to the heat exchanger, which is U2. Let's open it. One more shutoff valve, yay! Next we open the PIRCA-free control valve. It's in manual mode, so we will open it for 10% to check. Also, it's written in the instructor. The idea is the same, to check that everything is working correctly, to understand that everything is okay. And the next step is to open the next shutoff valve, U3, here. So we will also open it. Okay. And the next step is to turn on the pump. But here there is a point and the idea why we can't always and every time simply follow the instructor. Why? In order to turn off the pump, there must be enough liquid in the column cube. But we see that the amount of raw material in the column is very, very small. As you can see right now, it's like 3%. Yeah. So is very, very small, and accordingly the pump will have nothing to pump out, and this can lead to the emergency, and we need to wait till it will be at least 45-50% to ensure smooth opening of the pump. In general, it will already let you to open the pump as soon as it will be to the maximum emergency level. I guess it's something like 10% here. Yeah, if you will try to press the pump switch now, if you will try to press the button to switch on the pump right now, it will turn on, as you can see, for a second, and after that turn off, because the emergency protection will be triggered. I will show you once again. So for example, look, we opening the pump. Actually, instructor also showing to us that the action is followed and you did everything true and you did everything correct, but it's not like this because our pump is not working. It's the emergency protection simply turned it off. Yeah, so right now the level is almost 12%. Right now I guess it will let you to open the pump, but it's still critically low, and I suggest, and technologically it will be more correct and most careful for the equipment to turn on the pump when the level is at least like 20-25%. The best way is to wait till it will be in its middle value, so at least 50%. Yeah, when my brain works hard, it needs some ventilation. That's why it's not that I want to sleep. It's just the brain works hard because I'm trying to explain you something here. Yeah, so we are waiting the column to fill. Let's wait till it will be at least 20-25%. Yeah. And after that, we will turn on the pump. Let's wait till 25. It's quite fast. Okay, so I'm tired of waiting. Let's turn on the pump, but I suggest you to wait every time till it will be in normal position. So it will give you, let's say, the better points, first of all, and secondly, the better, of course, using the equipment in general. So let's start the pump. As you can see right now, it started and it's showing and it's working. And the next step, we will open the valve on the Z9 right now. Yeah, discharge on the pump discharge, manual valve on the pump discharge. And we watch now that the column cube is filled and the flow rate on the column is being established. As you can see, soon it will come to the normal position. Okay, so far there is only monoethanolamine in the column. We didn't, as you remember, open yet and direct gas to the column for cleaning, because first the column cube needs to be well filled. This needs to be done for a good gas cleaning, so we will wait until the cube is 50% full. Oh my gosh, our call will finish in 15 minutes. Today I'm a little slow. But in general, I'm trying to explain you the topic good. That's why the time passing so fast. Yeah. If something, we will just re-enter in the same link, okay? But I guess we will be on time. So yeah, we will wait until the cube will be 50% full. And after that, we can fully open the valve on the pump discharge so that a good stable flow rate of 100 is achieved. Yeah, let's open the automatic mode. So it will ensure the faster opening. So Lyric 4 is currently in manual mode, as you can see here. And we will now switch it to automatic. We always do this for the distributed control system. Yes, so let's switch it to automatic mode, so it will faster go to the 50%, because in general the system will make it 50%, which we need to let the gas for purification to enter to the column. So in automatic mode, I put the set point which I need to achieve, pressing enter, and right now it will be faster. Faster opening. So yeah, after that, and to it's already opened. Okay, to turn it on the cascade mode, and right now having moved to the operator's field. Wait, let's turn it to the cascade mode, so that they will work like hands and eyes, as I already mentioned. Lyric 4 as a level device will measure the level in the column, and Firka 3 device as hands will control the valve. So we will move right now to the operation field, and we can see that the amount of raw materials leaving the column has increased because the device began to work in cascade mode. So in general, soon it will take to the normal normal position. Yeah, just let's wait. Soon everything will be normal. And next, according to the instructor, you need to open the cutoff valve U5. We will open it, and with this action, we will open the path for gases. Okay, so let's open it. And as soon as you can see, our level already entered 50%. FIRCA-free device is also get out from an emergency mode. Everything is okay. We wait enough, and all the things are working good right now. So our next action to let the gases to enter to the column. So right now we can open the Z1 manual valve. We will gradually open it with the mouse wheel, and we will open the gas path to the column. Okay. Passes through the column tube, where there is, of course you can't see it because of all these open things. Okay, so now the gas enters the column, passes through the column tube, where there is monoethyl amine, which entered from here. It is cleaned there and passes through the column clean and goes to the boundary of the unit. Next, we need to heat the monoethanol amine in the heat exchanger. To do this, you need to open the coolant supply, circuit valve device, click to the instructor, open circuit valve manually by 10%. The idea is the same, to make sure that everything works well. Next, open the manual valve at the outlet of the hot coolant supply. So click on the instructor. Also, let's go to the Z valve. We will fully open it. Okay, and right now we will enable the circuit valve device to the automatic mode. Okay. Automatic. So now it will be automatically controlled. And let's put the set point. Right now it's 65. Let it be 61, because 65 is the highest border of what instructor is suggesting to us. So yeah, sorry. And we're going to the next step. Actually, it was the last step. Okay, so also, despite the fact that we have completed all the actions which instructor is showing to us and which in general should be done, the exercise cannot be considered completed. Why? Because as you can see, not all of the device display normal values. As you can see, our last device, TIRC12 device, is in emergency mode, in emergency situation. To finish the exercise, we need to see that everything working correctly, and everything, every device shows the right things and the right points. So we need to wait till TIRC12 device will show us, will become white directly, like right now. So yeah, right now, as you can see, the situation is okay, and right now we finished the startup of the exercise, and I guess we will not go to shut down. It will also be your home task, because our time of the session will finish. So I hope you understand the main idea of the startup. So shutdown will not be hard for you. Yeah. Always welcome. Always. Any problems, you can every time write to our technical support. You can every time use our WhatsApp chat. We will try to help you as soon as possible, because it's also our main goal to fully show you and explain you how everything working. So yeah, as I see, my colleague Denise is answering for your questions. Thank you so much. Thank you so much for these sessions.